Welcome back to our Chapter 2, Basic Concepts of Derivatives and Their Applications. Now we are in Part 3 on our topic, Application of Derivatives. The first, Optimization. We have the learning objective, formulate a mathematical equation that models a given verbal problem. So now we are going to deal with mathematical equation and talks about a given problem. And then in solving optimization, take note, we need to show explicitly the step-by-step development of our solution. So as a student, you need to show explicitly the step-by-step development of your solution, since that is crucial in getting the answer of the given problem. For example, a delivery company wants to come up with a package box that has a square base and a volume of 40 cubic feet. What should be the dimensions of the box with the least amount of materials to be used? First, we sketch the box properly and label the lengths of its sides. Note that a box with a square base means that the variable can be represented as x, while the variable y can represent its height. So first, we're going to draw the box. So after making the drawing, we need to identify first the part of the box. So according to the explanation that we are going to use the variable x and the variable y. So in this case, the base, which is square base, we're going to use the variable x, this side, and then the height, we are going to use the y. Moreover, we have the volume of 40 cubic feet. So the formula is V, or the volume, equals 40. And take note how we are going to get the 40 cubic feet that is came from the x squared times y, or the base times the area of the base times the height. And then we need to solve for y in terms of x. So what is the purpose of writing y in terms of x? The reason is to make, in order to us to express the function to be minimized in terms of a single variable. So instead of x, we're going to use y para mas madali natin and we can minimize and we can express the terms a single variable. So we have y equals 40 over x squared. According to the problem, we're going to minimize the amount of materials. Means that we want the surface area, or our SA. That is surface area. So we need to find the surface area of the box to be as small as possible. The required function for this problem can be derived from the formula surface area equals 4 the area of the sides, since the box has a 4 sides, plus 2 times the area of the bases. So meron dalawang bases po si box at apat na sides. Writing this function in terms of x and y results to surface area equals 4. So for the sides, meron tayong part ni x at ni y. So we have 4xy plus 2. And take note for our bases, we are going to focus only the base, which refers to the x times x for top and bottom. So we have 2x squared. But we have to express the function in terms of one variable. So in this case, we're going to choose x. So we have SA. We need to choose x for SA equals 4x. Tapos yung y, pulihan nato sa value niya, na 40 over x squared. Plus 2x squared. Simplify. Surface area equals. So here we can cancel x, tapos 1. So 4 times 40, that is 160 over x plus 2x squared. So for this case, we're going to take the appropriate working interval. So we can have the half closed. So closed here, 0. Tapos we have positive infinity on the other side. Just open. So the value 0 in the interval would mean that you will not construct the package box. And positive infinity, ibig sabihin, you have an abundant, unending supply of resources. However, we are aware that 0 is not a valid value for this problem. Hindi pwede si 0 since yung company nag-aim to produce a material. And also positive infinity cannot happen since there is the economic concept. Gusto nila makatipid due to scarcity of resources. So thus, if ever there is a value that makes the surface of the box minimum or maximum, the x value must lie in the open interval. So hindi ito na interval yung gagamitin. So we have open interval 0 and positive infinity. So this value, if it exists, comes from the critical number of surface area. So now we are going to compute the critical value of the surface area. So our SA is equal to 160 over x plus 2x squared. So to get the surface, the critical numbers, we need to derive the surface area. For 160 over x using the quotient law, or the rule in deriving this one, di na lang natin ipapakita. So we got negative 160 over x squared. So just use the given derivative law. And then 2x squared, we have 4x. And then next, get the LCD, which is x squared. So we have negative 160 plus 4x cubed. And then we need to equate this one into 0. We have negative 160 plus 4x cubed over x squared equals 0. So x squared times 0. So yung natira na lang is negative 160 plus 4x cubed equals 0. Transfer natin po yung negative 160 using the addition property of equality. So ganyan. And then, divide both side by 4. So yung natira is, divide po natin ng 4. So x cubed na lang equals 40. Then, get the cube root. So x equals cube root of 40. So this will be our critical number. Okay? So our critical number is x equals the cube root of 40 feet. Now next, we need to subdivide the interval. Yung interval natin is open interval 0 and positive infinity. So we need to subdivide this one into two open intervals which contain cube root of 40 as our endpoints. Okay? So we are going to use the lesson in the previous topic. So first, we need to make a table. So first is we have subinterval, subintervals, and critical numbers. The next column is our SA, which is our x equals 160 over x plus 2x squared. Next is the derivative of this one. Then the conclusion. So we have 4. So yung gitna natin is cube root of 40. Tapos yung una is 0 and cube root of 40, since that is our critical number. Then here we have cube root of 40 and the positive infinity. So ayan. Okay. So based on our previous topic, in this part, we're just only going to solve for our x using this given equation. So substitute lang natin po yung cube root of 40, then simplify. So we get 160 over cube root of 40 plus 2 times cube root of 40, the square of cube root of 40. Approximately, yung result po niyan will equate to 70. Now, in this part, we're going to solve for this open interval and also this one. But here, since this is critical number, ang pipilian lang dito is 0 tapos undefined. Since we have the number 70, so this is 0, automatic. And then here, pipili lang tayo ng mga numbers in between or within this open interval. So, for example, you're going to choose 1. Substitute natin dyan. So, the result is probably having the sign of negative. Diba? Ganyan yung nasa previous lesson natin. In this part also, if you're going to substitute any number between this one, the result is positive. So, di na lang natin ipapakita to save time. And now, since we have negative, so our surface area is decreasing. And now for 0, surface area has a relative minimum value. And here our SA is increasing. Therefore, the required dimension of the box are x equals the cube root of 40 feet. Ito yung required na dimension po ng box as the sides of its square base or the side of square base. And ry equals 40 over x squared. Substitute lang natin. We got 40 over the square of cube root of 40, which is equal to cube root of 40. This is our height. And this is our side. Okay? Feet. However, more often than not, people do work with a limited source due to scarcity of material. Thus, we introduce an important theorem that we applied for the rest of this lesson. So we have the theorem 2.5.3, the extreme value theorem. According to the theorem, if a function f is continuous on a closed interval AB, then it has an absolute maximum and absolute minimum value on closed interval AB. So, simple lang. Pag si f is continuous on a closed interval, then it has an absolute maximum and absolute minimum. And this theorem confirms that the required maximum or minimum values exist. This can be obtained either at the endpoints of the interval I or the closed interval AB, or at the critical number of f in the interval. That will be our remark on this theorem. So we need to follow some steps, and the first two of which can be interchanged. And they are necessary to make full use of the said theorem. The theorem, the extreme value theorem. So we have step 1. So po yung step 1 at step 2, pwede yan magka-interchange. Determine if the function is continuous at the specified closed interval. And then number 2, find the critical numbers if there is any of the function in the interval. For step 3, find the values of the function at the critical numbers and at the endpoints. And step 4, the highest function value obtained in step 3, yung pinakapataas na function value sa step 3, that will be our absolute maximum. And the smallest function value will be our absolute minimum. Example, find the numbers in the interval I equals close interval 1/2 and 3 such that the sum of the number and its reciprocal is a maximum or a minimum. Since the problem requires at least one number to satisfy the clause, the sum of the number and its reciprocal. So isang number lang yung hahanapin natin para mabigay natin yung sinatawag na the sum of the number and its reciprocal. And we have to form a function for this. Let x be the required number except 0. Kasi yung 0, wala po siyang reciprocal. So, let x be the required number if it exists. Since we are still to establish it po, there is such a number. Kung meron bang number na ganun. Now, we have the function for this problem given by f of x equals x. Nakabase po tayo dito sa statement na the sum of the number and its reciprocal. So, yung number natin dito is x, yung x plus yung iyang reciprocal. The domain of the function is x such that x is not equal to 0. And the interval I is a subset. Interval I, 1/2 and 3, the closed interval rather, is a subset of the domain. This means that f is continuous or x is continuous on I. Bakit? Since yung 0, hindi po siya element ni I. Diba? 1/2 and 3. So, 1/2 in between 1/2 and 3, wala po dyang 0. Since here, we stated that x is not equal to 0. By the extreme value theorem, we are assured that the absolute maximum and the absolute minimum exist in this interval. But how? First, we determine if there is a critical number for f in the interval. Then, the derivative is, so to get the critical number, derive natin to. So, derivative po ni x, function x, is, derivative of x is 1. 1 over x, derivative po nito, using the quotient rule, we have 1 over x squared. Since 0 cannot be a critical number, even if it makes f undefined, we set f of x equals 0 and solve for x. that makes it such. Equate natin to. 1 minus 1 half 1 over x squared equals 0. Then get the LCD, which is x squared. We have x squared here minus 1 equals 0. So next, we have x squared minus 1 equals 0. So we get x squared equals 1. So square root niyan. So we get x equals positive negative 1. And that is our critical numbers. However, note, tignan na. Yung critical numbers need natin is positive 1 tapos negative 1. And take note, negative 1 is not an element of 1 half and 3. Hindi po siya kasali sa elementang 1 half at 3 sa closed interval. Therefore, yung i-consider lang natin is yung x is equal to positive 1 as our critical number. Now, evaluating f at the endpoints of the interval as well as the critical number, we get yung end po natin, we have 1 half and 3. So, yung x, 1 half, plus 1 over x, 1 half. Solve po natin. So, which is equal to 1 half, plus 2 over 1. So, we got 2 and 1 half. And then, for our critical number, which is 1, we get 1 plus 1 over 1. This is the value of our x, 1 over 1. So, the answer is 2. And then the endpoints, which is 3. So, 3 plus 1 over 3. So, we have 3 and 1/3. This means that the absolute minimum value of f, the absolute minimum value of f is 2. Why? Kasi si 2 yung pinakamaliit na number dito. At dumating siya, of course, when x is equal to 1. While the absolute maximum, yung pinakamalaki na number, maximum value of f is 3 and 1/3. Nakuha naman when our f is equal to, or our x is equal to 3. Now, next example, a wire measuring 12 feet long is cut into 2 pieces. One piece is to be bent into a square and the other into a circle. How should the wire be cut so that the combined area is as small or large as possible? The perimeter of the form square, yung perimeter po ni square, tapos yun ni circle, should add up to what? 12 feet. Dapat yung perimeter ni square at ni circle, total niya is 12 feet. Therefore, the problem requires the formula of the perimeter of both the square and the circle. That is, the perimeter of the square is P equals 4 sides. And yung circle naman, yung perimeter niya, P equals 2 pi r. So this is for the square and this is for the circle. Now we let x feet be the length of wire for the square and the remaining material. Ito po yung length ng wire po sa square. Yung wire po sa square. Tapos, yung natira, diba, 12 feet yun, minus yung feet ni square yung natira, that will be the length of wire for the circle. So, yung x plus 12 minus x equals 12 yan. So, pwede interchange. Pwedeng ito, pwede kang square yan, at ito din pwede kang circle. And we get the same result. Representing the sides of the square and the radius of the, di ba? Side yan. Tapos radius po ng circle. In terms of x, we get what? For our s, we got x over 4. This is for our side. No? Since that is our parameter. Right? So to make this one clear, so we got p equals 4s. So instead of p, we're going to use x. And then to get the side, so we got s is equal to x over 4. That is for our square. And then for the circle, our p now is 12 minus x equals 2 pi r. Now find r, the radius. We got 12 minus x all over 2 pi. Since we have to optimize the combined area of the square and the circle, we form the objective function that represents the sum of their areas in terms of the variable x. So, ano po yun? So, we have f of x equals, we have the s squared plus the square of our radius. So, substitute natin. So, our s is x over 4, the square of that, plus pi. Yung r natin is 12 minus x over 2 pi, square of that. Then solve natin. We get x squared over 16 plus pi. Tapos, yung the square of 12 minus x over 2 pi is 144 or 144 minus 24x plus x squared all over 4 pi squared. So, we can cancel pi. Yung natira, x squared over 16 plus 144 minus 24x plus x squared over 4 pi. Next, get the LCD, which is 16 pi. 16 pi divided by 16, we have pi. So pi r, pi x squared. Then the other side also, 16 pi divided by 4 pi. We get 4 and times mo yan. So simplify. The result will be the square, the result will be pi plus 4 is the common here, x squared minus 96x plus 576. So just solve that. Then we need to get the derivative of this one. So derivative based on this solution. So the result, if you're going to solve this one, and the derivative of our x is equal to 1 over 16 pi times 2 times pi plus 4 x minus 96. Okay, so if you are going to derive this one, now we are going to find the critical number. So simplifying this one, we get the critical number, which is x is equal to 48 over pi plus 4. So equate mo lang to into 0, which is equal of 6.72, and 6.72 is an element of our open interval 0 and 12. So 0 and 12, that is base po sa length niya na 12. Note the interval 0 and 12 serves as our constraint. The material that should be cut cannot exceed, bawal po siya lumagpas po sa total length ng wire, which is 12 feet. Now, applying the extreme value theorem for the function f over the interval, ito yung closed interval po natin, 0 and 12. We have, so substitute natin po yung value. So first, we have closed interval 0 and 12. So here our f is equal to f of 0 using this one, the square of x over 4 plus pi, and the square of 12 minus x all over 2 pi. So since our x is 0, substitute natin. So dito na part, wala na tayong magagawa dyan. 0 na yan. So the square of 0 over 4 is 0. We get pi times 12 over 2 pi, the square of that. 12 times 12, that is 144. And then we have 4 pi squared. Times pa natin sa pi. Cancel. 144 divided by 4. We get 36 over pi. So which is approximately equal to 11.46 square feet. That is if our x is equal to 0. Now next, if our f is, or our x is equal to 12, so we got 12 over 4, square of that, plus pi, 12 minus 12 over 2 pi, and the square of that, so equals, we got 144 divided by 16. Here, 0 na yan. Makita lang natin. So we have 0. Okay. So, ito na lang yung natitira, which is equal to 9 square feet. And the last one is our f. Our x is equal to 48 over pi plus 4. So, plus pi, 12 minus 48 pi plus 4 all over 2 pi. So, when you're going to solve this one, you will end up to 5.04 square feet. That is our f, when our x is equal to 48 over 5 plus 4. That is our critical number. So, balikan natin if our f of x, where x is equal to 0, it gives 11.46 square feet, which gives the area when only circle is formed out of the wire. Pag circle lang yun. And then, f of 12, which is equal to 9 square feet, which happens when the wire is bent only as a square. And then, the last is f of 48 over pi plus 4, which is equal to 5.04 square feet, which occurs when the wire is cut into 2 pieces. Ano po yung measurement? Babalikan natin. This is for the circle, this is for the square, and this is the measurement when the pieces, or when the 12 feet wire will be cut into 2 pieces. So we can have the x is equal to 6.72 feet, which is in turn formed into a circle and a square. Hence, we have a maximum area approximately. Ito po yung maximum area po natin. 11.46 square feet when the wire is simply formed into a circle. And ang minimum po natin, minimum is 5.04 square feet, which happens when the wire is cut into two pieces. So approximately, you can cut this one, yung 6.72 feet can be formed to a square. Tapos yung 5.28 feet can be formed into a circle. So that's it for our application of derivatives. First derivative, optimization, part 3. The problem solving.